This algebra lesson is going to look at similar figures and the means extremes property. So ratios of lengths of similar geometric figures are equal, leading to many applications and proportions. And so a very famous property with solving proportions is the means extremes property. A proportion is a statement that two ratios are equal. So ratios can be written with colons. Therefore, the extremes are the outside numbers and the means are the inside numbers. So, for example, I could write 2 colon 3 equals 6 colon 9. And so we would call 2 and 9 the extremes. And we would call 6 and 3 the means. They're the middle. So that's where the name comes from. And so it comes from the ratio, or the colon form for ratios. 2 is to 3 as 6 is to 9. But more importantly is the means extremes property, which says that for all real numbers a, b, c, and d, b and d cannot be 0, if a over b equals c over d, then AD equals BC. And so to use these numbers right here, if I set up this proportion, which is already solved, right, there's nothing I have to find, that means that 2 times 9, those are the extremes, is equal to 3 times 6. So the product of the extremes equals the product of the means, which you can see very clearly. 18 equals 18. So let's look at an example. Here are two right triangles, CAB and FDE, with different sides given. We would say these shapes are similar because they have the same shape. They're not congruent, but they are similar. I would find x, which is the distance of A to B, by setting up a proportion. Solve the proportion by using the means extremes property, and I would check by calculating the two ratios. And those ratios would be called ratios of similitude, which means that they have the same number. So over here, these are ratios of similitude. The ratio of the means and the ratio of the extremes are going to equal each other. Let's take a look at these numbers with the right triangles. So I know that 5 corresponds with 3. Those lengths are similar. They have the same ratio of similitude. And that equals x divided by 4. So 5 is to 3 as x is to 4. I could also do 3 is to 5 as 4 is to x. Same thing. And now what I'm going to do is cross multiply. I know that the product of the extremes equals the product of the means. And so 20 equals 3x divided by 3, and x is equal to about 6.9. That would be the distance between D and E, and that would be an approximate answer. So the fundamental property of similar figures says this: if two polygons are similar, then ratios of corresponding lengths are equal, and corresponding angles also have the same measurement. So let's say that we have an adult African elephant that's 30 feet long, 11 feet high at the shoulder, and a baby elephant is 3 feet high at the shoulder. We want to know what the length of the baby elephant would be. So the ratios of similitude have to do with the height of the adult, the height of the baby, versus the length of the adult and the length of the baby. So a proportion that I could set up, and there are others that would also get me the right answer, but I know that 11 is to 3 as 30 is to x. So multiplying the extremes and multiplying the means give me 11x equals 90, which is about 8.2. So we would estimate that the baby elephant is slightly over 8 feet long, and that would be a pretty good estimation. Let's try this one. Two quadrilaterals are similar, corresponding sides are parallel. I want to find CD. Well, I do have a corresponding side on the bottom quadrilateral, and that's 12.6. So 12.6 is to x, and now I have to stick with the bottom quadrilateral as 4.8 is to 3. Use my calculator here to figure out the product of the extremes and the product of the means, which is 4.8x. But 12.6 times 3 is about 37.8. Not about, it is 37.8. So 37.8 equals 4.8x. Right, I cross multiply here. Divide by 4.8x, or just 4.8 rather. So x equals 7.9. 7.9. Now how do I check this? Well, I check this by doing two different ratios. So 12.6 divided by 7.9 has to equal 4.8 divided by 3. They have to be equal to each other. So let me check that. 12.6 divided by 7.9 is about 1.59. 4.8 divided by 3, 1.6. So my ratios have to match, and then I have to go back here. My answer is 7.9. So let's take a look at one other example here. What if I have two different flagpoles, or one flagpole rather, and then I'm comparing that to a ruler or a yardstick, which is 3 feet in length, and I want to know what the height of the flagpole is based on the shadows. So h is what I'm looking to find, and so I know that 72, that shadow is basically proportionate to 5 for the yardstick, and so I need to write h divided by 3. That would be my proportion that I would have to set up. And then I would cross multiply. 72 times 3 is 216. So that equals 5h. Cross multiply. Divide by 5. And h equals 43.2. So the height of the flagpole would be 43.2. And again, I could check this. 72 divided by 5 has to equal 43.2 divided by 3. Those ratios must equal each other, so 72 divided by 5, 14.4. And does that equal 14.4? Of course it does. So that's my check, but again, my answer is right there. 43.2 is the height of the flagpole. So those are some good examples setting up proportions using the means extremes property. And that's it for this lesson. Thanks for watching.